Hello everyone and welcome to Group 1's presentation on collaborative networks. My name is Anita and today me and my group will be covering a whole lot of fun topics. So for our agenda today, Nate and I will be covering the development portion of this presentation. So I'll be covering the theory of collaborative networks, their origins and usage. Next, I'll hand it over to Nate, who will be covering the historical to current transition into the use of collaborative networks as well as their drivers of demand. Next will be Amy and Randy, who will cover the application portion of the presentation with a couple of case studies of collaborative networks. They'll be looking at a couple of case studies between university and oil industry partnerships. Finally, will be Aaron and JP, who will round out the evaluation portion of the presentation and give us a couple of things to think about while participating in collaborative networks. So at the end of each section of the presentation, so the development, application, and evaluation portions, there will be a couple of questions for you guys to think about and you guys to share your thoughts, hopefully on the course site, and let us know your thoughts. So just a heads up, I'm a huge SpongeBob fan, so don't be surprised if you see a lot of SpongeBob references in the next couple of slides. So there's all this talk about collaborative networks and collaborative network theory. So this begs the question, what are collaborative networks? Collaborative networks are defined as a group of entities that are autonomous, geographically distributed, heterogeneous in terms of their operating environment, culture, social capital, and goals, and are typically supported by a computer network. Despite the differences in the entities that make up a collaborative network, these entities collaborate to better achieve common or compatible goals. Collaborative networks, as I'm going to use the term pretty often, are otherwise known as CNs. These CNs might even be extended to competitors. This is known as coopetition instead of competition. So with the definition of collaborative networks, we can move on to why they exist. CNs exist because they can achieve goals that might be implausible otherwise. The idea behind CNs is that together, the network members can achieve goals that would not be possible or would have a higher cost if attempted by them individually. CNs also encourage innovation and resource pooling. In that sense, CNs are a lot like people. We can't do a whole lot individually, but we can do a lot as a group. Now with the groundwork for collaborative networks, we can now define what the theory itself is. The theory itself is fairly simple. Companies join together to become more competitive and to share scarce resources. The idea behind the theory is that CNs provide improved competitiveness and resource sharing for the entities involved. With the theory comes 4 different perspectives on what CNs do. CNs can be considered resource pools, which is an ecosystem of financial, human, relational, infrastructural, organizational, and informational resources that are available to partners. Resource pools help organizations identify and develop innovations. This is what we'll be focusing on more in this presentation. The second perspective for CNs are e-business initiatives. So with the rise of internet and cloud-based platforms, members of value chains can better communicate. E-business initiatives are based on data exchanges and ICTs, which stand for Information and Communication Technologies. The third perspective of CNs is industrial symbiosis. This symbolizes a physical exchange of materials, energy, water, and byproducts. The key idea behind industrial symbiosis is that one company's trash is another company's treasure. This perspective considers CNs to be driven by collaboration that creates symbiotic networks and new knowledge creation patterns. The last perspective on CNs is known as innovation clusters. Basically, CNs are networks of innovators. This perspective centers around the idea of collaboration networks being made up of entities that are jumping onto the next innovation. With this discussion in mind, I'd like to show you guys a video that I found was a great metaphor for the collaborative network theory.
Singing, are you? Teamwork. Oh, brother. We can do anything when we have teamwork. Don't you think so, my friend? No, teamwork is getting in the way of my skiam work. What don't you comprehend? But working together is the key. Nothing's impossible when it's you and me. I'm doing just fine on my own. Work is no fun when you do it alone. If I want it done right, I'll do it by myself. But what if you need something on a higher shelf? Well, I'm the target of a very scary, crazy, post-apocalyptic mob. Well, that's exactly why you need a partner helping you with this important job. I'll be the hammer, you'll be the nail. I'll be the boat and you'll be the sail. I'm the flower, you're the aroma. Right now, I wish I was in a coma. Come on, I'm here for you and you're here for me. It's better when you plus me equals we, working together in harmony. Side by side we can reach our dreams, cause nothing's impossible when we're a team. Alright, you can put me down.
So I hope you enjoyed that video as much as I did, and hopefully it gave you a better idea of what collaborative networks are all about. So next I'll be explaining the origins of collaborative networks. Collaborative networks emerged from 4 different evolutions that took place in the environment, in technology, and in the world in general. The first evolution is market evolution, and this refers to globalization, increased emphasis on core competencies, customization of products, and volatile market demands. The second evolution is called supply chain evolution, and this refers to global competition for more efficient processes and requiring closer collaboration in the supply chain. The third evolution is business environment evolution. This refers to shorter time windows for business opportunities as well as shorter product life cycles. The final evolution is technological evolution. Technological evolution refers to the reduction of communication costs and causes organizations to constantly pursue innovation. This way, they can insure themselves from obsolescence and imitation by competitors. You might be surprised to find out that the actual discipline for collaborative networks was actually established quite recently in the 2000s. Interestingly, the study of CNs did not start out in general theory, but rather evolved backward from specific types of CNs like virtual enterprises and virtual organizations. There will be a figure on the next page that describes this in a little more detail, but I'd like to just briefly go through the backward development of CNs. First came virtual enterprise, which is a temporary alliance of for-profit entities that share skills, core competencies, and resources to respond to business opportunities. After virtual enterprises came virtual organizations, which is pretty much the same thing as a virtual enterprise except for nonprofits. CNs really became a concept as companies began to look outside themselves for help and collaboration, as well as with the innovation and progression of computers. Computers could help companies connect and transcend geographical boundaries that had existed before. So here's the figure that details the progression of the study of collaborative networks. So as you can see, back in the 70s, it started all on the floor. It started from a very micro level view of the organization. And as we go on to about the 80s into the 90s, there's more of this focus on intra-enterprise, which means looking at the organizational processes within the bigger scope of the organization. As we go into the 90s, there's more of a study on inter-enterprise. So this is where companies start to look a little more outside themselves and think about how to work with other companies. So in the late 90s, we start seeing the emergence of virtual enterprises and virtual organizations. And finally, in the 2000s is when collaborative networks emerged. And it's more of this integrated focus on organizations in general. So it's not just how can I work with you and what can you offer me, but it's more of how can we work together to achieve our common goals. So CNs have been seen and used in a lot of different sectors, but historically they've been used in education, tourism, and the public sector. So we'll be focusing a little more on education later on in the presentation. So why do we use CNs? What's the point of them? What benefits do they offer that an entity can't have on its own? The idea centers around risk sharing and knowledge sharing. So our textbook lists a few reasons why CNs are so beneficial. CNs involve sharing risks when entering new markets, mounting expensive new programs and reducing costs, and enhancing an organization's profile in selected industries or technologies. So in addition to the risk and knowledge sharing, there's also cost sharing that is involved. So an entity may not be able to implement a new program by itself, but by spreading the costs out among a couple of different partners, an entity can roll out a new program. Additionally, CNs can respond easier to environmental pressures as a group as opposed to an entity by itself. So say that economic conditions take a downturn, CNs, because they have a whole lot of partners, can better handle the strains of economic downturns as opposed to an entity by itself. So this relates to the next point, which is that CNs provide an increase in survivability for the partner organizations. There's also a possibility of better achieving common goals by excelling individual capabilities, their access to new and wider markets, new knowledge, sharing of risks and resources, focus on an entity's core competencies, innovation, and creation of new value. So that's sort of a mouthful, but the idea is that partners in these CNs kind of work like puzzle pieces. Instead of an entity trying to do everything all at once, an entity can focus on what it's really good at, so its core competencies, and basically join up with other partners who have complementary skills and capacities to achieve a common goal. In the old days, it would be a lot harder to do all this, to use collaborative networks and work with partners. But since technology and globalization have helped in that area, CNs are a lot more efficient and usable. It's interesting to note that partners should be ready in advance and prepare to participate in CNs. If they're not ready to participate, it usually doesn't end well. So these firms that usually are averse to collaborative networks are in very competitive industries, and the very common example is pharma. So pharmaceutical companies usually don't like entering CNs if it involves competitors because they don't want to share the knowledge they have. So this goes back into why organizations should be willing in the first place to participate in CNs. So, one metaphor for these sort of hesitant organizations, like pharmaceutical companies, can be seen in this video.
I don't need it. I don't need it. I definitely don't need it. I 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 need it!
So I hope that video gave you a little bit of a laugh, as well as an understanding of why some organizations might be hesitant to get involved in CNs despite their benefits. So now I'll be handing it over to Nate, who will be covering the historical to current uses of CNs, particularly in university and oil industry partnerships, as well as their factors of demand.
Historically, companies operating in collectivist cultures were early adopters of collaborative networks. Researchers believe this to be the result of social and cultural factors. In Japan and Korea, collaborative networks were dependencies developed for navigating competitive markets. Individualist cultures have been slower to adopt these collaborative practices, choosing instead to focus on pure competition. However, in the last 10 to 20 years, technology has increased the speed and volume of information, as well as the velocity of money. This has fueled global industry connectivity, increased complexity, and decreased reaction time. To deal with these developments, collaborative networks are now widely adopted by U.S. companies as a method of survival. Particularly, there has been a surge in collaboration between universities and industries in natural resource-rich extraction environments such as oil production and mining, where there's a demand for research. U.S. universities such as Texas A&M and Colorado School of Mines have international satellite schools in oil-producing nations. They support the industry with research, training, and business process innovation. A new terminology has emerged for collaborative networks between universities and industry. These are called university-industry linkages, or UILs. This term is representative of the increasingly commercial roles universities play in both education, research, and industry innovation. These UILs are most often occurring in R&D heavy markets such as biopharma and natural resource development. The focus of our research is the collaboration between universities and oil companies seeking exploration and development research. One of the core competencies of universities is that they often have already performed research independently of any commercial initiative. As such, corporations view universities as knowledge centers that contain large information databases collected by experts and managed by highly skilled individuals. Another recent augmentation on the idea of collaborative network theory is the concept of strategic alignment, which is a bidirectional relationship for mutual benefit, in this case between knowledge centers and industry. An example of this is the comprehensive GIS mapping and seismic survey work done by the University of Alaska to help identify possible production sites. U of A also performs LiDAR mapping and economic impact assessments on the North Slope. In turn, industry supports these education systems through funding. Large oil companies maintain many such relationships and played a role in funding the UAF engineering building. Now we'll take a moment to discuss the factors that drive demand for collaborative networks. To stay relevant, companies must allocate resources to innovation. Interdependencies are formed organically as a natural division of labor with consideration to economies of scale and the high cost of R&D. As technology advances, developments and progress become more complicated and require more specialized approaches. An example of this is the breakthrough in fracking, which opened huge tight rock and oil sand reserves. Companies would struggle to maintain effective R&D completely in-house. One company that has adopted collaborative networks on a large scale is British Petroleum, which maintains research partnerships with 22 universities. Corporate social responsibility is also driving a holistic business perspective and an emphasis on good corporate behavior. For example, universities are able to deliver well-rounded exploration studies as well as environmental impact assessments. Another concept worth noting is that the mutual value exchange drives innovation. In the Middle East and North Africa, the Colorado School of Mines and University of Texas have played key educational and training roles, in addition to providing advanced research and work process consulting. As universities in turn receive funding from these industries, value is created for both parties. Finally, the silo approach to competition is no longer efficient or entirely effective. In this context, silos represent isolated and uncoordinated approaches to complex business planning and execution. In contrast, the new knowledge-based industrial environment is based on connectivity, not isolation. This is informed by changing business landscape, which has increased regulatory oversight, environmental responsibility, and the cost of new technology. Companies likely do not have all the resources to meet such demand. An example of this is the seismic exploration that has been conducted every winter on the North Slope of Alaska since at least 1976, with environmental records as far back as 1949. This is now being used to assess the long-term impact of oil development in the region. It's not hard to comprehend how oil companies could not have accomplished this without large knowledge centers, specifically UAF, to collect and manage the data. Due in part to this sort of collaboration, as well as interest from the Alaska Native corporations, the North Slope is one of the oldest and most comprehensive exploration and impact records in existence. Collaborative networks continue to be used today as knowledge and data shape the decisions of the future. We expect that knowledge centers such as universities will continue to operate on the cutting edge of research, and university-industry linkages will grow. I'll conclude by presenting you with an ethical question about possible unintended consequences of university-industry collaboration. Feel free to pause the presentation here to take time to read it. This concludes our discussion on the development of collaborative networks theory. In the next section, Amy and Randy will discuss its application.
Hello, dear classmates. Randy and I will be presenting on the second part of this project, which talks about the application of collaborative network in other organizations other than the ones mentioned in the textbook we are using. We will be given three forms of applications. All three are about the oil and gas industry. The first will be from a related personal experience. The second and third are in relation to other organization and outside material. From a personal experience, I witnessed and also took part in the collaboration and partnership that existed between my former employer, Technip FMC in Ghana, and KNUST, which is Kwame Nkrumah University of Science and Technology, my undergraduate university, where I pursued my Bachelor of Science degree in Agricultural Engineering. In the year 2012, a Memorandum of Understanding was signed between Technip FMC Ghana and KNUST. A year later, we signed another one with Regional Maritime University. The main objectives for these partnerships were: 1. To have a long-term partnership that will help develop local capacity in terms of training fresh graduates to have the expertise that are needed for them to eventually become independent to manage the country's oil and gas industry. 2. Was to conduct collaborative researches that can be implemented by the company in its work activities. Other key activities included: 1. that Technip FMC will organize an industrial seminar every quarter. 2. They will sponsor final year students to carry out an industry-based project. And finally, was that they had to provide a recruitment processor through internships, national service, and full employment. Additional activities include the participation in annual Industrial Partners Awards, Congregation of College of Engineering, an annual career fair that is organized by the College of Engineering. This is one of the main success so far through this partnership. 4 students from the Mechanical Engineering department were given this project topic as part of their final year graduation requirements. The topic was to develop an equipment management software, that's the EMS, to be used by the installation engineers for on-time certification of various installation aids. This particular project topic was given out to them in order to reduce the unproductive time that installation vessels usually experience offshore Ghana. This unproductive period happens when some adjustments or changes in the installation procedure is done and it requires a component which is not on the vessel. This component will then have to be retrieved from the equipment storage area, which is usually located offshore. After these components have been found, it is then transported offshore. This process usually takes about 2 days. If this retrieved component needs to be recertified, that will require about 3 days. The total number of days for the uncertified component to get onto the installation vessel is about 5 days, but with an already certified component, it will take 2 days. These 3 days will be unproductive for the client, and he will end up losing hundreds of thousands of dollars as a result of that. Other success programs also include the quarterly industrial seminars that are organized. Usually, what we do during these seminars are we present to the final year students in the mechanical and petroleum engineering departments some of our work activities, especially those of engineering design related. We also supervise the 2 project topics that are given to the final year students from the beginning till the end of every year. For the past 7 years, 116 students have worked on project topic that was proposed by Technip FMC Ghana. These usually last for about 6 to 8 months. 41 students out of the 116 were given the opportunity to have a 2-month internship with us. During this short period, they are able to get a summary of our various work activities. In Ghana, every graduate is required to carry out a year of service to the country before you start to work in the corporate world. What usually happens is that after the internship period, some students are given the opportunity to carry out their national service at our company. The criteria for selection is based on those who were hardworking and had good work ethics, good grades at school, as well as good human relationship. So far, 29 students have enjoyed this opportunity and 25 of them are currently working as permanent employees at Technip FMC Ghana. Technip FMC Ghana has also built and furnished a 30-seater IT center for students at the College of Engineering. Some of the challenges that Technip FMC Ghana and the University Partnership have faced so far include 1. The lack of efficient communication with students. KNUST is located in another region, equivalent to a state in the USA. It's about 4-hour drive away from Technip FMC and 30 minutes if you decide to go by flight. For that matter, it is very difficult for both parties to meet face-to-face very often. The main means of communication now is through telephone calls and emails, but unfortunately, we have come to realize that students hardly check their emails. The second challenge is understanding of the project concepts by students. Students usually find it very difficult to get a full understanding on the project topic that is given to them. This is usually due to the fact that the courses they study are very theoretical, and most of them do not have any internship experience from the corporate environment. The third challenge is the minimal logistics availability, such as a Visio system to facilitate discussion for clarification when needed. As we all know, communication is very integral to getting an efficient result in every endeavor. With that being said, the unavailability of a Visio system is a very big challenge that this partnership is currently facing. The good news is that both parties are currently working very hard to resolve it. I'll now hand over to Randy to continue with application of the theory from other organizations.
The oil industry partnerships at UAF today are with the Alaska Pipeline Service, BP Exploration Alaska, Hillcorp Alaska LLC, and ExxonMobil Global Services Company. Because of the frequency of research contracts, UAF and oil companies use master agreements, which have prearranged terms for contracts that only require new project proposals to have a statement of work, period of performance, and a budget. The objective for UAF is to conduct research focused on Alaska and the circumpolar Arctic, leveraging university resources with external grants and contracts. To make for successful collaboration, the agreements between the university and contractors are well defined. The key activities involved with these agreements is the collaborative research, but then later sets the stage for strong relationships to follow. While contractors with the university supply funds or team up with the university for research, other activities from the oil companies include donating funds for scholarships, research facilities, facilitating internship career opportunities. Taking another look at each individual oil company and its collaboration with UAF, we notice a few similarities. An example for collaboration is the Alaska Pipeline Service Company and the investigation into how unmanned aircraft systems could be used to monitor permafrost and unstable soils in order to develop pipeline operators. Leading this research is the UAF's Alaska Center for Unmanned Aircraft Systems Integration in cooperation with Alaska Pipeline Service Company. A few notable gifts from BP include $1 million that doubled the amount raised so far to have completed the fourth floor of the new engineering building at UAF. Another large gift was a $4 million equipment donation, also from BP, that made the University of Alaska Fairbanks Community and Technical College one of the only few programs in the nation to offer a working wellhead in a classroom. Total so far donated would be coming close to $30 million from BP. On top of research opportunities available at UAF, scholarships are available to students through the Alaska Pipeline AISES Scholarship for students who are members of the American Indian Science and Engineering Society at UAF that are pursuing education, training, development that leads towards careers on the Trans-Alaska Pipeline System. To best see the effects of the collaborative network, it's easier to see it as a cycle. UAF and oil companies first established the master's agreements that allow for easier contract creation. Then the research is done in collaboration with the UAF and oil companies, where information is shared back and forth. On top of the research opportunities for students, oil companies are also donating funds for facilities, as well as creating scholarships and career opportunities. Since these individuals who have already had experience with the company are later recruited by the oil companies, alumni later return to the university to serve as board members and directors of the varying programs, further strengthening the relationship through various touchpoints within the university and business. Difficulties that arise from the UAF and oil company collaboration would reflect those found in many university business collaborations that have already been mentioned earlier, including effectively communicating data, the protecting of market competitiveness, and aligning of overall research goals. Difficulties that are specific to UAF and oil companies is the relationship beyond research funding. UAF, as part of the University of Alaska, has recently seen a cut of almost 41% to be implemented over the next 3 years. This is in part due to the declining oil revenues that in 2017 made up for 43% of funding for the University of Alaska from the state. Because the oil industry has such a direct impact on the overall state funding, if oil revenue is low, as it has been in the previous years, it will impact research at the university on two different fronts, both from state funding and partnership funding. Now at this time, I'll be handing it off to Amy to talk about the application of collaborative networks in BP's 7 Partners Alliance.
I'm going to talk about application of the theory from other outside material. The first one is about BP's 7 Partners Alliance. The main objective for this alliance were to help reduce overall system costs and cycle times, and to ensure access sometimes preemptively to crucial technology and inputs. The specific objective was plan and execute the overall development of Andrew fields in North Sea. The main success that was experienced from this alliance was that their collective efforts resulted in a savings of about 20 to 25%, with actual project costs estimated at £290 million. Also, the production was able to begin 6 months ahead of schedule. And some of the challenges they faced included 1. Communication management. 2. Was how to tailor financial arrangements in a way that will reflect each other's contribution and ability to absorb risk. And finally was how to manage the risk that proprietary capabilities may be transferred inadvertently. That's all, and thank you very much for your attention.
To conclude the section on application of collaborative networks, feel free to pause the video now and examine the discussion question focused on the challenges faced by the 3 organizations examined. I will now hand it off to Erin to begin the evaluation of the collaborative networks.
Evaluation of the theory based on practical application. University-business cooperation works as a synergy between both entities. Businesses bring capital to universities in exchange for skilled laborers and researchers. As explained in our book, collaborative networks should do the following. They should consist of a variety of largely autonomous entities, be geographically distributed, should each work with a different operating environment, for example, culture, goals, and mission, and should utilize and share common databases with their collaborators. As university business cooperation has grown over the last couple of decades, evaluation of these partnerships has become increasingly important. In order for these collaborative relationships to work, they must be beneficial for all parties involved. It is also imperative to answer the following underlying questions. To what extent should universities be business-oriented, and to what extent should companies conduct their own research? To answer these questions, the motivations and obstacles of university business cooperation must be examined on a case-by-case basis. Each situation or collaboration cannot be judged the same. The following slides will look at these motivations and obstacles in more detail. Motivations play a powerful role in evaluating these relationships. Motivations that drive these partnerships include access to industrial knowledge, access to additional resources, institutional or organizational motives, and pursuing greater research efficiency. These motivations could apply to both universities and oil companies. In this particular case, universities are primarily motivated by the capital companies can bring. For example, BP and ConocoPhillips have been generous donors for multiple causes at UAF, and they keep funding research related to the development of the Arctic. Key examples are BP Design Theater, UAF Engineering Learning and Innovation Facility, BP's Intern Technofest, UAF Petroleum Development Laboratories. Obstacles can prevent these partnerships from occurring. Evaluating obstacles can help determine if the relationship will be beneficial to both parties. These obstacles include deficiencies of firms as well as different interests and attitudes towards research. If the interests and attitudes towards the research of both parties cannot be aligned, it will not be a productive and effective partnership. For example, universities might be more inclined to research alternative energy, or they might not have enough researchers to work on a particular project an oil company would like to resolve. It is also crucial that both entities can read, exchange, or modify data in real time, which means that BP has to be extremely cautious with what to share since it could represent a data breach if mishandled. This is why it is important to set limits and expectations for each project that might be a collaboration. The evaluation doesn't stop here. When evaluating these collaborative partnerships, other factors must be taken into consideration. These factors include, but are not limited to, allocation of university funds, the size of the facility or university, the type of scientific field, and external funding. As for any other collaborative network types, infrastructure, capital, and trust must always be evaluated. In this current presentation, we use the university business model, but in a business environment, it is important to define the boundaries of the information shared. Since the information used to collaborate could also potentially harm competitive advantages a company has over another, boundaries are an important factor. How does geographical location affect these partnerships? According to the United States Geological Survey, or USGS, 25% of undiscovered hydrocarbon resources are contained within the Arctic. There is an ongoing need by oil companies for research as it pertains to the Arctic. It makes sense that the research should be performed by those who are experts within the field. UAF is considered to be the leader in Arctic research. This can be measured in different ways. Within the university setting, publications are used to measure research productivity. As can be seen in this graph, in terms of publications and citations of these publications, UAF ranks number 1 in Arctic research. UAF houses over 40 research centers, including the International Arctic Research Center, the Geophysical Institute, the Institute of Arctic Biology, and the Institute of Northern Engineering. It allows companies to decrease their R&D investments by downsizing in-house research and shifting to third parties, like UAF. Over the last decade, energy research and development investment has decreased. The Internal Energy Agency's July 11, 2017 report shows that oil and gas companies decreased their R&D spending by 15% in 2015, and spending continued to drop in 2016. However, universities have continued to shift their R&D functions to universities. This benefits these private companies because while they are good at short-term projects, they are motivated by profit and only have a short time to test their ideas. Universities have access to facilities and researchers and are in an environment where adequate time can be spent testing new ideas. The oil company's major focus is profits, but one of the university's main focus is publishing research. And with that, I will pass things off to J.P. Landry to continue discussing the evaluation of the collaborative network theory.
Thank you, Aaron. Now that we understand the importance of collaborative network, the benefits it brings to a university, a business, those partnerships needs to have some boundaries. It is important to understand that collaborative network is an excellent tool, but it should not derive the university from its primary mission, the students. Which brings us to this question: how can universities balance their collaboration with big oil companies? As we know, the climate change is actually opening many routes in the north. With the Arctic Circle and the Arctic temperature rising, it is expected that the projected permafrost boundaries and the ice sheet covering the sea will actually open, which will give trade routes a new way of crossing the Americas. It will also be important for national security, since Russia, China, Denmark, Canada, and other European countries are actually claiming a route through the Arctic Circle and the Arctic Sea. So for the United States, and thus the University of Alaska, more researchers will be favorable to have a better claim on those new routes. This can create a relationship that might cause conflict of interest for universities. The main point is that a university mission is for the students and the academic perspective it gives. When the researchers are taking too much importance, it is important to see that the shift of a mission can occur and the student could actually be delegated to the second rank in terms of priority. This is why it is also important for university that there is a need to consider if the funding is in alignment with their core academic and public interest functions. The University of Alaska in Fairbanks currently helps big oil companies and develops their petroleum engineering, their geology departments, and other engineering departments With the opening of the Arctic Circle, armies or national security matters might actually come and ask for a partnership or a collaborative network with the university. But is there a claim for that it could help students to better understand a certain topic? Maybe. But the point is that it is important for the university to stay focused on the academic matter of the research and on the students. So it is important that it is in alignment with also the public interest and the students' interest. One conflict that could also happen on the other side for private organization or for armies or for the government is that they have a limited control on the information that is researched. And if a new research appears, it is important to know that this research is most likely going to be public. So if there is research and development on a secretive matter, a collaborative network with a university might not be the best thing to do. In order to mitigate those conflicts for the university, it is also important to take into account those 3 points. The first one is to eliminate the financial conflicts of interest, if possible. A university has to do research based on a neutral point of view, while having many financial incentive does not give the right for universities to be biased in certain researches. It is also important to retain the academic control over the research selection and the independent peer reviewed. If a company is asking the university to do research, we should be able, as a university, to be able to have an independent peer review that would actually give more power to the research. We are not going to ask, for example, BP to tell us if the best place to drill would be the North Slope if we know that there would be an ecological impact on our salmon. Also, it is important to minimize the delays of research publication. As we pointed out a little bit earlier, it is important to see that because when you minimize the delay in research publication, the university gets credits on those researches and it helps the advancement of a cause for other university by sharing that information. So a company, even though they pay or fund or grant a certain amount of money for researchers, need to understand that the research will not necessarily stay private for a long time. Which brings us to the last part, the limits of collaborative network between companies or between a university and another company. It is important to understand that when you do a collaborative network, you share information. It is also illegal to share personal private information with others as per user agreements. An example would be credit card information, SSNs, student records, according to the FERPA regulation. This also goes for the medical field. You can develop cases, you can share cases, but no information that is personal, that could be directly related to a person, should be shared. If that would happen and there would be a data leak, both companies could be liable in that case, because they would possess ownership on both of them. Also, while collaborative network can be used for a project scale, a project, or a big research development project, there is no clear definition on who is the owner of that research. So if a patent or another discovery is filed under a company, both of them will be in a huge juridic battles in order to determine who has the right for what. Normally those clauses are already discussed in private contracts, but in the case that it is not, it will be extremely hard for a company to claim full ownership. Now that we talked about the collaborative network, here are 2 questions for you to understand and you could use for a real-life situation. We were mainly focused on universities and business, but can you think about a business-business collaborative network? Also, could 2 governmental organizations create a collaborative network, even if they technically work under the same organization, which is normally a criteria that we need to have, 2 different entities? To answer those questions, I invite you to read about supply companies like Coca-Cola and Dr. Pepper. Do they really have a collaborative network for shipping? Do you think that it would be efficient? Do you think that it would be great so that they could share that information in between them? Also, for the 2 governmental organizations, it is important to know that if the employer is still the government, their mission, their organization structure might be different. That will help you for those questions. Thank you.
Hi everyone, it's Anita again. Just to recap what we covered in this presentation, we covered the theory of collaborative networks as well as where they came from and where they get used. We also cover the history behind collaborative networks as well as their drivers of demand. We covered 3 different case studies of collaborative networks, specifically in the context of university and oil industry partnerships. And finally, we evaluated different factors to consider while participating in these university and industry partnerships. So I hope you learned a lot and enjoyed this presentation. Thank you all for listening.